In this video, we are going to take a look at the polynomial remainder theorem. So let's take a look at this function fx. A second. So this function fx is equal to x square plus 4x plus 7. And what we are trying to do is we want to divide this polynomial by x plus 1 and then see what we are trying to find out, what is going to be the remainder. So one way we could do is just use a long division that we have been using and try to divide this x square plus 4x plus 7 with x plus 1. What we can do is multiply this x plus 1 with x here, then we get x squared plus x, and when we subtract, we can subtract these two. So from 4x minus x, we have 3x here, then we bring down this 7 here, and then we multiply this x plus 1 with 3 till we get 3x plus 3. If I subtract this, I get 4. So 4 is the remainder, and that's something we can find by just using this long division. But there is another way to find the remainder very quickly. What we do is we set x plus 1 equal to 0. That gives us x as minus 1. And what we do is this minus 1, we try to find out the value of fx at x equal to minus 1. So let's see. F minus 1 is going to be x squared, which is minus 1 squared, plus 4 into minus 1 plus 7. This is minus 1 squared is 1, minus 4 is minus 3 plus 7. That is 4. So what you see is this number 4 is same as this. And why does it work? To understand it, when we wrote this function fx, what we did was, if I divide this fx by x plus 1, then we get here, what we get here is x plus 3. This is the result, x plus 3, and then this 4 is the remainder, so I can write it as 4 divided by x plus 1. That's the result that we have observed. Now what I'm going to do is multiply this whole equation by x plus 1. So what we get? Fx, if I multiply this by x plus 1, then x plus 1 cancels out. So we get fx here, and we get x plus 3 multiplied by x plus 1 plus 4, x plus 1 cancels x plus 1. Now in this equation, if I write x plus 1 equal to 0 or x equal to minus 1, we get f of minus 1 equal to, this term becomes 0, so this whole terms become 0. So we have a remainder of 4. So that is the reason why these things work out. So let's see how we formally state this polynomial remainder theorem. If a polynomial fx is divided by x minus a, then the remainder of the division is fa. In the previous example, we see that fx was nothing but fx was x squared plus 4x plus 7. If I divide this polynomial by, let's say, x minus 1, for that matter you can divide by x minus 1 or x plus 4 or x, whatever you want, then the remainder of this theorem is given by f1. So for example, if I divide it by x minus 1, the remainder is going to be 1 plus 4 plus 7 or equal to 12. You can find it, you will be arriving at the same result using a long division formula. So let's take a look at some example. This is the kind of the problem that you could be getting in your SAT exam. So this is a relatively simpler problem. If px is equal to 3x square minus 5x plus k is divided by x minus 1, then the remainder is given to be 4. I don't know why it's not going on, but let me try. Okay, it's gone. Okay, whatever. So I'll try to do it in this way anyway. Wanted to make sure you view it correctly. So if this is the polynomial, and if this polynomial is divided by x minus 1, then the remainder is 4. If I divide it by, what I can also say is that if this polynomial is divided by x minus 1 equal to 0, then the remainder is given by p1. This is the remainder. That's from the polynomial theorem. And p1 is nothing but 3 into x squared, which is 1 squared, minus 5 into 1 minus 5 plus k, and that they are saying is 4. Now 3 minus 5 is minus 2 plus k equal to 4, or k is equal to 6. That is the D should be the answer. So hope this clarifies. There could be more kind of problems that you should try to solve, and hopefully this is going to help you. Thanks for watching.